Good day and welcome to Model Railroad Academy. I'm Ron Marsh, one of the contributors here at Model Railroad Academy and your host for today. And today we're going to be talking about setting up switches to power switch machines for your layout. Now, if you have a layout of any size, from the smallest, module, small switching layout to a large basement empire, there's a good chance that you are using some remote switch machines on your layout. Not all of us do that. I personally have hand thrown my switches for years, but I'm in the process now of transitioning over to remote switching for my turnouts, and I'm using switch machines to do that. And today I want to talk to you a little bit about powering those switch machines and how to remotely throw them. Now, most of us, when we talk about switch machines, we're most familiar with the Tortoise. This is a Tortoise switch machine right here. It's a slow motion switch machine. Inside of this case is a DC or direct current motor. And literally, whenever power is put to this motor, depending on the polarity of that power, it will throw the motor, and I can do it manually. You'll hear it whir here. There you go. And it throws an actuating rod which moves the switch on the turnout at whatever speed based on the current that we're sending to this, but moves it in slow motion and moves it remotely. And with this, we can throw our switches using our DCC system. We can do it using toggles that are on the fascia. We can do it from a computer or from a CTC type machine where a dispatcher is controlling the switches on our layout. We can do it from all kinds of remote places, which is part of the fun of using these switch machines, the fact that we can do it remotely and automate that part of our layout and keep from reaching in, which is kind of an unrealistic action within our layouts themselves. So understanding switch machines, and also it's going to say this is a Tortoise. Again, this is the most popular. There are other types of switch machines made by different companies, and many people are building their own switch machines these days using things like Arduino control boards and micro servos. And that's another way that you can do this as well. But today I want to talk specifically about how we power and how we throw remotely switch machines like the Tortoise, these DC switch machines. And specifically what I want to talk about is using a toggle switch to do that. Now, this toggle switch can be mounted on the fascia, as I said, so that whenever we need to throw a switch, there's a toggle right there that we can throw on the fascia right in front of the switch where we are operating. Or this could be set up in a control board where it's done remotely by a dispatcher, kind of like a CTC machine. We could use a CTC type switch, but we're going to talk specifically about toggle switches today. And what we have to do in order to throw a switch machine like the Tortoise is we have to change the polarity in order to get it to throw the other direction. Again, it's a DC motor, so it runs similarly to a DC train set. Whenever we flip the switch one way, the polarity is set a certain way. The train moves in one direction. When we stop it and throw the switch, we switch the polarity so that the current is running the opposite direction from the DC system, that direct current system. The train runs the opposite direction. The same with a Tortoise switch machine. The little motor inside, where it is positioned and how it runs is dependent upon the polarity that it receives. So if we want to switch the motor, it's a matter of taking the power that's running to the switch machine and switching its polarity. And I'm going to show you an easy way to set up to do that using a double pole, double throw switch. Now, if you're not familiar with electronics and you don't know what that means, I'm going to show you exactly what that means in just a moment. So now I'm going to go ahead and turn the camera down to our workbench here as we take a look at this switch and see what we need to do in order to get this set up to use with our switch machine. So first, that explanation of a double pole, double throw switch. You can see here I have a basic toggle And there are two types of toggles on double pole, double throw switches. Some of them will have what's called a center off position, in which case when it's flipped one way, it'll be turned on. When it's flipped the other way, it'll be turned on for something else, which I'll show you in a moment. And then there's a position in the middle, which is an off position. And you can use that type of switch for what I'm going to do today. I think that center off position for what I'm doing is unnecessary, and for me, I just don't care for it. So I prefer to use what's called an on-on double pole, double throw switch. Up is on, down is on a different way. Let me describe to you what that means. On the back of the switch, you're going to notice there are 3 pairs, or a total of 6 little terminals. And as we look at the side of the switch is how we need to think about those terminals as being paired. This is a pair of terminals on one end, a pair of terminals on the other end, and then a pair of terminals in the middle. And the way this switch works is whichever way power is flowing through it, whenever the switch is thrown up, I'm going to call that up, then you see the back of the switch points down. That means that the lower set of terminals here are connected to the center set of terminals. However, when we throw the switch the other way, now this set of terminals is disconnected. The switch is going this direction, so this set of terminals is connected to the center terminal. And that allows us to do a couple of different things with a double pole, double throw switch. If we're putting power into the center terminals, then we could use this switch to turn on one thing or another thing. For example, if we had a diverging route on our layout and we wanted only one of the 2 routes to be powered at a time, we could run power through the center poles here and then run the power out to one track on one set of poles and to another track on the other set of poles. And then when it's thrown, whichever way it's thrown, only that track will be powered. Actually, today we're going to use it in kind of the opposite direction. We're going to put power into the outer terminals and allow the switch to connect that power to the center set of terminals. But the thing that we want to be able to do is reverse polarity on a direct current or DC system. So what we want is positive and negative to be hooked up on one set of terminals one direction, but on the other set of terminals we want it to be switched around the other way so that the polarity is opposite whenever it flows into the center terminals, and then the center terminals will go out and power our Tortoise or our switch machine. So I'm going to show you an easy way to do that wiring today. Now I also want to say this, the switch that I have here is a somewhat large double pole, double throw switch. I prefer larger switches. A lot of people use smaller switches. They're called micro or mini double pole, double throw switches. The whole box is much smaller, the switch is smaller, and the back terminals, instead of having these screw terminals, they usually just have little loop terminals for each of these. And those will work just as well. They will handle plenty of power to do what we're doing with a switch machine. I prefer these because I like the bulkier toggle switch, and also as I get older, it seems like my fingers get a little less nimble. My eyes aren't as good as they used to be. It's just easier for me to work with these larger terminals. Also, you'll notice that this switch has screw terminals. Each terminal has a little Phillips head screw in it, and that's what I'm going to be using to connect that. You can also solder these wires, and if you're using the mini or micro switches, you'll probably have to solder the wires because there are no screws in those. So first of all, let's get our power wires routed into this switch. Now I've got just a pair of wires here, and this is how I typically wire these. I'll wire them with a set of kind of pigtail wires here. These are about a foot long, one red, one black. And then whenever I install my switch, I'll just take the other end of these and either solder them into or use spade connectors and a terminal strip and connect them into my power, however I prefer to do that at the time. But the one thing that is helpful here is I am using solid wire. This is actually 22 gauge solid wire. Now you can do what I'm going to do with stranded wire, but it's a lot more difficult. You got all those little wires to deal with, and this is just a lot easier to do with solid wire. Now the first thing I want to do is I want to strip this wire, and I'm going to strip it on the end so that I can curl it around one of these terminals. But I want to strip a little bit of extra insulation off of it, and you're going to see why in a little bit, and I'll show you and explain to you in just a few moments. But I'm going to come down and strip a little bit of extra, and I've got some wire strippers here that I'm going to use for that. If you've just got the manual wire strippers, those work just as well. So I'm going to just pull that piece of wire completely off of here. And I've already gone in and loosened up all of the screws on my terminals here, so they're ready to go. And then I'm going to come in with a pair of needle nose pliers, and I'm going to curl that into a U shape. I'm just going to kind of grab the end and curl it around so that it'll wrap around my screw. And I'm going to go ahead and connect that into one of these screws right here. You see, I'm just hooking it behind the screw there, and then I'm going to come in with a screwdriver and tighten that down. Now, I want you to notice, let me tighten this down, and I'll tell you what I want you to notice. There we go. I want you to notice that these terminals have a little crook up here at the top, and that's made to help keep your wire straight and under control. You could stick the wires out the sides of these if you wanted to, but this is really made to help control your wire. So I'm going to make all my wires go up and over that little crook, that wire guide. Now, remember, we want to be able to reverse polarity as it comes into these from one way to the other way. So what I'm going to do is I'm going to connect my wires across this from corner to corner in an X. That way, when the power is running through, it's going to connect to the black and red in one way on one side, but in the opposite way on the other side, and that's what's going to reverse my polarity. So I want to connect this same wire again into the screw terminal that's on the opposite corner from the one I just connected. Now this is why I left a little extra wire there, because I want to keep my insulation in the center here so that my wires don't short out. So what I'm going to do is I'm going to come and I'm just going to estimate about how much wire I need to strip here. And about there looks like what I need, right where I'm holding that. I'm going to keep this wire solid because this is going to be my pigtail that I'm going to connect this into. And I'm going to come here with my wire stripper, and right where I marked with my finger, going to strip that. And you see what it did there? It literally just pushed this wire back up, push the insulation back up the wire. Now I've got still got just a little extra there, so I'm going to try to take that little bit off there because I do want it to connect in. I want it to touch this terminal. Probably not crucial that it do that right there because I'm going to wrap it around the terminal itself, but I'll have better connection if I do, so I'll feel better if I do. Okay, like so. And there, you can see now I've got the insulation across the center part, but the wires are connecting into these terminals. Now I'm going to take this wire and just bring it down, and I'm going to wrap it around the screw terminal. Now, one tip: whenever you're wrapping wire around a screw terminal, it's helpful. It's not an absolute must, but it's helpful if you wrap it in the same way that you would tighten the screw. That way, as you tighten the screw, it'll actually help wrap the wire tighter around the screw rather than be loosening it. So I'm just going to take this wire and wrap it around that screw. You see how I've got a nice wrap there? And then I can come in with my screwdriver and tighten that down. And now I have a nice pigtail ready to go. We're going to repeat that exact same process over here with our red wire, just the same way as we did before. Start by stripping the end here, and again we're stripping a little extra wire. Okay, and then I'm going to use my needle nose pliers, trying to make sure I'm doing this where you can see it in the camera. I'm going to bend that into a U with my needle nose pliers. I'm going to hook it on this terminal, the screw of the terminal. If I can get it straight, there we go. Bend it around good and tight there. I'm going to tighten that screw down. And then I'm going to come over here and figure about where I need this to strip, and it's about there. And strip that back up. And that's really in a good position there. And again, I got a little more here than I need. It's just a matter of the difference between what I need to keep it insulated across here, and then the difference between that and what I need around my terminal. Now, I'm going to bend this down and wrap it around this terminal again, just like I did before, and tighten that screw down. I'm not soldering these, so I want to make sure that my screws are nice and tight. I mean, there's no vibration, you know, to the model railroad that should loosen those, but I want them to be tight. Okay, and there we go. That's got the power routed in on from these two pigtails that come in from my bus, and then you see these are insulated, so they're not going to touch one another. Now I need two more wires to go out from the center terminals that will go out to my switch machine. In my case, I always just use a pair of black wires here. I use red and black on coming in because those will connect to different poles of my DC power source. When these are coming out, depending on which way it's thrown, it will change as far as which goes which way. So really the color doesn't matter. And by making them both the same color, I will always remember, and I'll always know that, okay, those are powered, and their polarity depends upon which way the switch is thrown. Now I just stripped the insulation off of those just enough to wrap around the terminal. In this case, I don't need any extra. I'm going to come and bend both of those into a U shape here, just like I've been doing. And let's see, I need to loosen that terminal. And once again, get that connected in. There we go. Hold that in position. Tighten it down. And then one more on the other side, exactly the same way. Like so. There we go. All right, that's got my switch completely wired and ready to go. Now, whenever I install this, of course, I would probably connect these into, depending on how far I am from the switch machine, they could connect these right into the switch machine. And of course, on Tortoises, it's got lots of pads here that we can solder to for various things, but controlling the motor is switch pads 1 and 8, so the very two outside ones. So I would simply take these and solder these into, that's the wrong, oh no, I just haven't stripped that one. I would solder these into pads 1 and 8 on my switch machine, and then when I have power in, it would be ready to go. I didn't really talk about how to power these. Again, with this switch, we're kind of assuming that you're not powering these with your DCC system. To do that, you would want to wire this into a stationary decoder. But in my case, I use an external or a separate power source for my accessories, and I run a power bus, a 12-volt power bus, and I would just connect these right into that power bus to be able to go, and we would be ready to be able to remotely run our Tortoise switch machines. So that gives you the basics of how you can use a double pole, double throw switch in order to throw the rod on a remote switch machine like a Tortoise. And it's really easy to do, and it honestly, in my opinion, adds a little bit of fun and some realism to the operations of our layout. So this is the type of project that you may want to give a try as you're building your layout and thinking about adding remote switch machines for your layout. Well, I hope that you have a great day, and I hope that you take the opportunity to allow your trains to bring some joy and enjoyment to your life today. Until next time, we look forward to seeing you then.